Alright, today we are going to go over this little review. Okay, so everybody should have out the review, even if you didn't do it, so that we can go through it together here. All extra copies are over there. So the first two problems were algebraic proofs. Okay? So we are just solving the equation and then justifying each step. So the first line should just be the problem itself. And the reason is given. So now we just want to solve this equation. So the first step in solving this would be to distribute this 8 through. So 8 times x would be 8x. 8 times -1 would be -8. So my reason for that, distribution or distributive property. Now, we want to get the x's on one side and the numbers on the other. So we could do that a couple of different ways. Yeah, we could subtract the 5x over first. So if I subtract the 5x over, 8x minus 5x would be 3x minus 8 equals -35. And my reason for that would just be subtraction. I subtracted that 5x over. Now we want to get the numbers onto the other side. So to do that, I will add the 8 over. So we end up with 3x equals -27. Right? -35 plus 8 would be -27. So my reason for that would be addition. I added 8 to both sides. On Friday, I did see a couple of people just skip from step 2 to step 4. Right? They just went from 8x minus 8 equals 5x minus 35 straight to 3x minus 27. When we're writing it out in a proof form like this, we can't do that. Okay? Because we did different things. Right? We subtracted something from both sides. We added something from both sides. So we would need to write out each of those steps. Right? And then finally, to solve for x, I'm going to divide both sides by 3. And we end up with x equals -27 divided by 3 is -9. And I mean, they tell us what the answer should be. So I better get x equals -9 at the end. So my reason for that would just be division. Questions on this first one? All right. Let's take a look at number 2 then. So, same idea. We just want to solve this equation, justify each step. So, my first line is the problem itself. -3 times 2x plus 7 equals -29 minus 4x. My reason for that is given. Now I just want to solve. So just like the last one, my first step would be to distribute this -3 through. So -3 times 2x would be -6x. -3 times 7 would be -21. My reason, distributive property. Now, I want to get the x's on one side, the numbers on the other. Okay? Technically, it doesn't matter how I do that, right? But I'll go ahead and add 4x to both sides. I'm going to add because this 4x up here is negative. So -6x plus 4x is going to be -2x minus 21 equals -29. So my reason would be addition, because I added something to both sides. So the addition property. Now, I want to get the numbers over to the other side. So I will add 21 over to here. So we get negative 2x equals negative 29 plus 21 would be negative 8. So again, that's the addition property. And then finally, to get x by itself, I'm going to divide both sides by negative 2. So negative 8 divided by negative 2 is positive 4. And that is what we wanted to get. So the reason for that is division property. Okay. We okay with the algebraic ones? I think these ones were a little more straightforward than the other ones. Okay. Any questions on these? These ones are the easier ones, yeah. So let's go ahead then and take a look at the geometric ones. Just a little bit. All right, so on this one, we're given two pieces of information, right, which they put in the first two lines. Q is the midpoint of PR, and R is the midpoint of QS. So both of my first two lines are given. Then they say, well, if Q is the midpoint of PR, then somehow they claim PQ equals QR. If Q is the midpoint, why am I allowed to say PQ equals QR? We're told that Q is the midpoint of PR. Why am I allowed to say, well, that those two halves of that segment would be equal? Amanda? That's the definition of midpoint. Definition of a midpoint is that a midpoint cuts a segment into two equal pieces. So if we're told something's a midpoint, and we're told, well, those two halves are equal, that's definition of midpoint. Okay, and they do that for both of these. They say, well, if Q is the midpoint of PR, then these two halves are equal. And if R is the midpoint of QS, then these two halves are equal. So we've got PQ equals QR, and QR equals RS. So from that, then, they conclude that PQ and RS are equal. Not definition of congruence. The definition of congruence is like when we're going from two things being congruent to those same two things being equal, or vice versa. Sebastian? This one we could use transitive, right? If we look back at line 3, I've got two different things equal to QR. You got PQ equal to QR and RS equal to QR. So if I get two different things equal to the same thing, I can say those two things are equal to each other by transitive. We could also use substitution here. Okay, we could say that I'm substituting RS in place of QR here. Okay, because those two things are equal. So either transitive or substitution would work here. Now, to go from line 4 to line 5 here, okay, what happened to both sides of the equation? What happened to both sides of the equation here to go from line 4 to line 5? Right, we added PQ to both sides. We went from PQ to PQ plus PQ, and RS to PQ plus RS. So I added the same thing on both sides. So that's just the addition property, right? So now what changed from line 5 to line 6? Yeah, we just simplified or combined like terms, right? All that happened was PQ plus PQ became 2PQ. So we can either write that as just simplifying or combining like terms, either way. So now from line 6 to line 7, the only thing that changed is PQ changed into QR, right? So we're allowed to do that because up here we said those two things are equal. So yeah, this one would be substitution. Now I think the next one, might be the trickiest one on here because it doesn't necessarily follow from what we've done before, right? If I try to substitute things in or look for missing pieces, right, this doesn't really follow from what we've already done. But if I look at the diagram, okay, it's saying QR plus RS equals QS, right? So this piece plus this piece equals the whole thing. That's going to be segment addition postulate. They conclude that 2PQ equals QS. Why am I allowed to do that? Yeah. So we would actually have to look back at lines 7 and 8 here. I've got the same thing, 7 and 8. I've got QR plus RS and QR plus RS. So what we're saying is these two things are equal to the same thing. They're both equal to QR plus RS. So if I've got two different things equal to the same thing, we can say they're equal to each other. That's a transitive property. Yeah, then the last one, I just want to think about more like an equation, like an algebraic equation. So we go from here to here, and just divided both sides by 2, right? Those 2's cancel out, and we just get PQ over here. And then over here, dividing by 2 and multiplying by half of the same thing. Right? So we could have division here. Okay? Questions on that one? All right, let's take a look at the other segment one here. So on this one, I get 2 pieces of information, and they both show up in this first line. Okay, those are both given. So then they say, well, if I know these 2 segments are congruent, why can I claim that their lengths are equal? If I know 2 segments are congruent, why can I claim that their lengths are equal? Yeah, that's the definition of congruence, right? If we're saying 2 things are congruent, then those same 2 lengths are equal. That's definitely congruence. Well, now they claim that AE plus EB equals AB, and CE plus ED equals CD. Why would I be allowed to do that? Yep. I think you've got the right idea. What's that one called, Sebastian? Not for line 3. Yeah. Right? Yeah, this one would be segment addition postulate. Right? So we're saying this piece plus this piece equals the whole thing, and then this piece plus this piece equals the whole thing. So that's going to be segment addition. So now they say CE plus EB equals CD. Okay, this one I think is a little bit tougher. Anybody, or can anybody see what's happening from line 3 to line 4 here? Okay, if we look at this equation to this equation, we have two things that changed. AE changed into CE. Well, I can do that because I know they're equal. And also AB changed into C because I know those are equal. So I substituted two different things in here. But that's still just substitution property. Well, now, somehow they claim CE plus ED equals CE plus EB. Why can I do that? We can use transitive here. Yeah, if I look, we actually have to look back at lines 3 and 4. In these two equations here, I've got CD on the right side. I've got two different things, meaning CE plus ED, CE plus EB, both equal to the same thing. I can say they're equal to each other. That's transitive property. So now, how do I go from line 5 to line 6? Subtracting CE from both sides of the equation. Canceling out on both sides, and we're just left with ED equals EB. And then finally, if I'm saying these two lengths are equal, why can I say that those same segments are congruent? Not property. If two lengths are equal, I can say that the same segments are congruent by a definition of congruence. Questions on that one? All right, then the last page was the angle proofs. So on this one, we are given two pieces of information again, so fill those in first. So line 1 is one of my givens, and then also line 3. So make sure that you always fill in your givens first. Well, now, if angles 1 and 2 are complementary, why am I allowed to say that their measures add to 90? Wait, say it again. Which one was it? Not of a right angle. Definition of complementary. So if we're talking about a right angle, we're talking about one angle being 90 degrees. If we're talking about complementary, we're talking about two angles adding to 90. So now, they say angles 1 and 4 are congruent. Why then can I claim that those measures are equal? If I know two things are congruent, why can I claim their measures are equal? Definition of congruence. Now, somehow they claim that angles 2 and 3 are congruent. That doesn't really follow from anything we've talked about, right? We haven't said anything about angle 3 yet. Like one thing about angle 2. So let's look at the diagram. What's the relationship between angles 2 and 3? They're vertical. Okay? They're right across from each other. So whenever I have angles that are right across from each other like that, they would have to be congruent just because they're vertical angles. So my reason would be vertical angles theorem. It's a little warm in here. So now, if I know that angles 2 and 3 are congruent, why can I say that their measures are equal? Definition of congruence, yeah. If two things are congruent, I can say their measures are equal by the definition of congruence. So now, they claim that the measure of angle 4 plus the measure of angle 3 is 90 degrees. Why can I do that? Together, they're a right angle. What's it? Well, so if we look at the diagram, angle 3 plus angle 4 doesn't really create another angle. For it to be angle addition, that's kind of when we're saying, like, this angle plus this angle equals the whole thing together. So that's not really what's happening in this picture. This one I think is a little bit tougher to recognize. We actually kind of have to think of all the way back to line 2. Say, well, I'm substituting the measure of angle 4 in place of the measure of angle 1. And I can do that because I know those are equal. And then I'm substituting the measure of angle 3 in place of the measure of angle 2 because we just claimed that those were equal. Okay, so this one was probably a little bit tougher to recognize. Okay, but this one would actually be substitution. And then finally, if two angles add to 90, why can I say that they're complementary? If two angles add to 90, why can I say that they're complementary? Definition of complementary. Okay, definition of complementary is the one that says if we have two angles that add to 90, then they're complementary. Okay. Any questions on this one? Alright, then the last one, the shortest one on here. So I'm actually given two different things, right? I'm given JKM and MKL form a linear pair, so that's my first line. And then I'm given JKM and LKN are supplementary, so that's line 3. So of my 4 reasons, 2 of them are given here. So now, if JKM and MKL form a linear pair, why can I say that they're supplementary? So yeah, I mean, if we have two angles that form a linear pair, we know that they're going to add to 180 together. What's the name of the definition or theorem or postulate that lets me say if two angles form a linear pair, then they're supplementary? Sebastian? This one would be supplement theorem. Okay, the supplement theorem is the one that lets me say if two angles form a linear pair, then they're supplementary. Okay? Well now, I've got angles JKM and MKL supplementary, and JKM and LKN supplementary.
Right.
So they jump to, well, these two angles are congruent now. Why can I say that those two angles are congruent now? Not complementary. Yep. This would be the congruent supplement theorem. Okay, if I look at lines 2 and 3, I've got the same angle on both sides here. Okay, I've got I've got two different angles supplementary to angle JKM. If two different angles are supplementary to the same angle, then we can say they are congruent to each other by the congruent supplements theorem. Questions on these?